Welcome, everyone. The event is now live. John Waters, please take it away.
Hi, everyone. Welcome to the Hybrid Cloud Data Summit, sponsored by cloud solutions provider and hyperconverged infrastructure pioneer, Nutanix. Today's event was organized by the hardworking folks at Redmond Magazine, Virtualization and Cloud Review, and AWS Insider, who have brought together some of the best independent experts on today's topics. Thanks for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of 3 information-packed sessions. Before we get underway here, I want to go over a few housekeeping details with y'all. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time throughout the presentation. Please feel free to add your questions as they occur to you. We'll do our very best to get to all of them. Our sponsor, Nutanix, has provided some resources that can be found on the right-hand side of your screen. Please take a moment to check those out. And last but not least, at the end of the 3rd session, one lucky attendee will be receiving a Surface Pro, Microsoft's ultralight tablet featuring a laptop-class Intel Core processor, all-day battery, and HD cameras. But you must be present to win, so stick with us. And now it's time for our first session, Expert Hybrid Cloud Data Tips and Infrastructure Best Practices. For this session, we've called on technologist, content creator, and senior resultant, Howard M. Cohen. In his 35-plus years in the IT industry, Howard has held senior executive positions in many of the top channel partner organizations, and he currently writes for and about the IT channel. Howard is a sought-after speaker, an insightful observer of the technology landscape, and he's quickly becoming one of my favorite presenters. You're in for a good one. Take it away, Howard.
Thank you, John K. Waters. And hello, everybody. I'm Howard M. Cohen, and I'm here to talk to you today about hybrid cloud data tips and infrastructure best practices. And the first thing I want to tackle is that there really are no best practices yet. If you think about it, the practices are first now being developed. We're first really emerging with getting things done. So this is more like expert hybrid cloud data tips and infrastructure suggested practices, recommended practices, practices to think about. So you're here at a very early time, and we hope that you'll participate by sending us emails and comments about what you think the best practices are after you've had a chance to work with this for a while. Okay, so I'm here to talk about all of this stuff, but really I'd like to break it down and just kind of focus in on 3 particular words. And those words are hybrid cloud data. I think those are the 3 most important words in this title. And since I'm a writer, I'm all about words. The first word I'd like to tackle is data. Now, I noticed that Scott Becker is now on the call. He just recently joined. It's a good thing because here's his favorite slide. I try to include this in literally every presentation I do that Scott's going to be watching or involved in. But it is my data is the new bacon slide. And a lot of people hear me say data is the new bacon, and they say, what does that mean? Well, it's a good question. Actually, a lot of people say data is the new oil. Bottom line, data is something that people value highly. They just put a very high value on data, and well, they should. It helps them run their business. In fact, most people have found out that their data are among their most valuable assets. Now, for those of you who are saying your data is, you're wrong. Data is the plural of datum. Just wanted to clear that up. And actually, when you come down to it, you have to manage data based on their value relative to your other data and your other assets. It'd be foolish to spend more protecting a body of data than that body of data is worth. And that's a thought process you need to go through whenever you're planning any kind of technology project. So I just wanted to start off by clearing that up. Okay, so back to the word data. And we talked about protecting data. The security of data, it's your responsibility. We're going to be talking about hybrid clouds, so multiple clouds are involved. Your cloud providers, they'll contract to provide protective systems and devices, and that's great. But at the end of the day, the fiduciary responsibility, the responsibility to your stakeholders, that stays with you. If you think about it, if, God forbid, it's corrupted or lost or stolen, who's going to lose their job? Certainly not the cloud providers. They may lose your contract. You, on the other hand, it could be a career-altering event. So, always keep in mind the data, you're responsible for it. The other high point about data that I want to refresh, and I probably have said this in a million presentations, and you've probably seen it in a million other places, data must always be encrypted, whether it's in transit between locations or at rest in storage. In other words, all the time. Why? It's the same reason that you have guards in basketball or in hockey or in soccer. If everybody gets through the front lines, that's that last line of defense. And indeed, encryption is that last line of defense. People talk about data leakage, how if somebody gets at your data, they could steal it and they could use it. But if it's encrypted, it's all completely scrambled, so they can't use it unless they have the key. And by the way, never share your key with a cloud provider. They don't need it. They have no use for it. Your payloads are not of interest to them. Never, ever share your key with anybody other than those who are supposed to use it. The other reason, though, when you have data in the cloud, to keep it encrypted has to do with the relationship with the government. And this is a best practice. Because it's encrypted, the government can come along and subpoena your data from your cloud provider. And if you look in your contract, most cloud providers will simply cough it up. They will simply hand it over. They will not resist a subpoena. I'm tempted to make 1,000 jokes right now. But they will not resist a subpoena. They will simply hand over your data, and nobody will inform you. You will never know that the government has taken your data. If, on the other hand, your data is encrypted, the government is going to have to come to you to get the key. Now, when they subpoena the key from you, you do have to turn it over. You don't have a choice. But at least now you know the government has your data. So in terms of best practices, if you learn no other practices from this session and you haven't got this already, learn this here. Always, always keep your data encrypted, whether it's in storage, whether it's traveling, and always protect and manage your keys like your life depends upon it. Okay, so we've beaten the death out of the word data. Let's take a look at the word cloud. Most of you probably remember the early days of advertising, to the cloud, let's take it to the cloud. And it's kind of like, I am the great and powerful Oz, ignore that man behind the curtain. The cloud isn't like that. It's no big mystery. Okay, the best definition I've seen is that the cloud is an assembly of data centers, and they're all connected to the internet. They're all run by professionals who know what they're doing, know how to back the data up, know how to run the security software, know how to keep everything under tight management, and they provide content to users who are also connected to the internet. That's what the cloud is. It means you can get rid of your servers, you can get rid of your storage, you can give that all to the cloud. Put it all in the cloud, and you don't have to manage any of that anymore. And a lot of people love that. Which brings us to the word hybrid. Okay, so what means hybrid? Well, rather than fool around looking for definitions, I usually turn to the National Institute of Standards and Technology. NIST wrote that famous 4-page definition of cloud computing, and if you haven't read that, you must. It'll take you about 10 minutes. Just to hunt for the NIST definition of cloud computing. It is the original. It's where everything else stems from. It is the holy grail of cloud computing. Their definition for hybrid is that it's a composition of either two or more distinct infrastructures, either public, private or community clouds. They remain unique. They're bound together by proprietary or standardized technology, and they enable application and data portability. Portability is the most important word there. Okay, the idea that you can move things around quickly. One of the things I love to say all the time is that data only gains value in motion, when it's transiting from one place to another. That's the only time it picks up value. Data sitting still is just data sitting still. So the more portable we can make it, the more we can move it. The more we can move it, the more money we can make. That's a good thing. And so NIST says it's different types of clouds all working together in a single platform. Okay, so they mentioned 3. I'm going to focus on 2 of them, really. Private cloud is all for one company. Now, notice that the definition I'm giving you here doesn't say that it's all for one company in some remote data center. The fact of the matter is that since 2012, when it was introduced, Windows Server, as an example, has been called the Cloud OS. And many people build their cloud servers on-prem. It's not a matter of where the servers are. It's a matter of how well they adhere to the NIST definition of cloud computing. Is it self-service? Is it pooled resources? Is it rapid request and release? Those are all the characteristics of a cloud. Is there a level of abstraction between the user and the technology? It's all in that definition. If your server in your prem obeys those rules, it is a cloud server, no matter where it is. And since it's on your prem, it's probably private. You can certainly configure a private cloud on somebody else's data center so that nobody else has access to it, and many people do that. So again, you have the ability to have that server, that cloud, that system of servers, that cluster, all to yourself. Usually referred to as infrastructure as a service, IaaS. Then there's public cloud, which basically is self-service access to pooled resources, including computing, storage, applications, and more. We all use public cloud, okay, or software as a service, SaaS. As a matter of fact, the recent stat that I saw is that 2/3 of cloud utilization is public cloud, storage as a service. I'm sorry, software as a service. I say we all use it, and if you shop on Amazon, you're using software as a service, you're using the public cloud. If you use Microsoft 365 or Google Apps or any of those productivity suites, that's public cloud. There are many other public cloud services that are available to you. And then the third is on-prem. Some people still have plenty of on-prem. Now, I wish that I could ask you to hold up your hands and ask you how many of you only use one of these 3. And I would bet you that no hands are being held up in all your areas where you are. That's because everything is hybrid. The word is basically useless. Everything is hybrid. I have not yet met anybody who is only using public cloud, or anybody who is only using private cloud, or anybody who has everything on-prem anymore. And before cloud, yeah, everybody was on-prem, nothing was hybrid. Now everything is hybrid, and I expect that it will remain that way for a good long time to come. Somebody's going to win the Microsoft Surface Pro later. That's a hybrid. It's a hybrid of tablet and laptop. And the Surface Book is a laptop that thinks it's a tablet. They're hybrids. Many people are still running IPv4. Some people are running IPv6. It's a hybrid if you're running both. And so everything is hybrid. The only thing that I personally think of that's not really hybrid are the systems that air controllers use to monitor the skies. That's the application. That's the one. That's it. That's not hybrid. They sit there and they stare at that screen all day, and if you're an air traffic controller, you're going to have to go somewhere else to use any other software. So some characteristics of hybrid cloud. You have broader choices. You have choices of all the services available to you in public cloud. You have choices of multiple different providers and multiple different services from a variety of private cloud providers, including running it on your own premises. There's terrific broad choice. You have consolidation of those choices. You get to pick what you consider to be the best of breed in every category. Best of breed productivity suite, best of breed backup, best of breed security. Whatever it is, you get to pick which you think is best, and you bring them all together in your cloud environment. So you get to consolidate everything. Another thing that's a big plus in hybrid cloud, rapid provisioning and scaling. You don't have to wait weeks for something to be delivered. You simply request more storage or more processing power or more memory, and you get it, which means that if you need more, you get it, and you need more, you get it. You're scaling effortlessly as much or as little as you need to, and it's truly effortless. We talked before about portability. Clearly, hybrid cloud is very portable. Wherever in the world you log in, you get the same experience. You get the same access to your data. It gets to you pretty much as rapidly, and certainly if it's slower because you're further away, it's microseconds. You can't detect it. So it's portable. You get tremendous adaptability. If you don't like something you've provisioned for yourself, get rid of it. Replace it with something else. You're not throwing away a big investment. You're not throwing away software that you purchased at extreme cost. You're not throwing away any hardware. So in hybrid cloud, you can adapt. You can find a public cloud service that would easily replace several things you're doing on your private cloud. Much easier to manage. You decide, yep, I want to go there. Fantastic, adaptable, and flexible. You can pick and choose. You can move things around quickly. You can rapidly change the way something works. If for some reason somebody compromises something, you can immediately change all the security on it, or you can shut off access to it very, very fast. So you've got all the flexibility in the world. The key underlying characteristic of hybrid cloud is that it's an exercise in pure integration. You're bringing all these different things together in one platform, and hopefully you're making them work as if they were one. Your users don't have to go to multiple places to get multiple resources to do multiple things. Generally, you try to bring everything down to one self-service portal that makes it really easy for them to do what they do every day without moving around. If you look around you, everybody, every provider of every kind of service is now trying to be that single self-service portal by adding integration capabilities to other applications. We'll see that continue for some time to come. Another fantastic value that you may not see very much is automation. Behind the scenes, the cloud providers are making extensive use of automation to speed things up, to routinize things, and to reduce their cost of operation, which translates into the continuously reducing cost of cloud services. They're not charging you less because they feel like it. They're charging you less because they can. They have found more efficient ways of getting things done. They're leveraging automation in new ways all the time. That translates to you in the form of the price you get to pay. They perform all the orchestration. You want things to go to different places, they can make sure that they go where you want them. And they make that very, very easy. For some reason, I've repeated integration. I apologize for that. Basically, we talked in, the title of this session talks about hybrid cloud and infrastructure. Realistically, your infrastructure has been reduced to either a router in your office that everybody shares internet access on, or turns into a wireless connection that you're making from your home or a hotel or the airport or whatever. you actually live with minimal infrastructure local to you. Most of the infrastructure is provided for and managed by your cloud providers. Now, if all goes well, there is a potential for you to enjoy unified management, bringing everything together under one console. And that's really, the ultimate goal. Relatively achieved here and there. It is certainly a best practice to get to that quote-unquote one pane of glass, but we don't always do it. And more tools are coming out to help you do it. And eventually, we will see development of platforms that lock it down completely. I look forward to that. That'll be interesting to see. Okay, so now that we've kind of reviewed what hybrid cloud brings to you, let's talk about building one, okay? Building a hybrid cloud environment. The first thing I'm going to talk about in terms of that is really an ancient concept going back to the earliest days of computing. And that is, or the earliest days of networking at least, it's the runbook. There may be a lot of people amongst you who don't know exactly what a runbook is because you've never heard of it. It's a term that is not used as frequently as it used to be, although some vendors have adopted it and adapted it. But a runbook was very simply the place where network managers documented everything. What's connected to what? What is the IP address of every device here on the network? What are the configuration parameters for every device here on the network? What software is running on what servers? How is that software configured? What are the master passwords for everything? Now, obviously, that makes the runbook something that needs tremendous protection, but you need to have a single source of truth when it comes to everything on your network so that when something goes wrong, you don't suddenly have to scramble to figure out where everything is, what did what, who installed that, do they remember what password they used, do they remember what IP address they assigned? You've all had those headaches. We've all experienced those headaches. When you have a runbook, you have one place to go. And my reason for bringing it up is simply to emphasize the importance of documenting everything, especially in an environment where you're using multiple cloud services. You're using a private cloud service over here, some public cloud services over there. You may still have things running at home. You may even be going multi-cloud, and you're using more than one private cloud provider or public cloud provider. So each of those has different parameters, different perspectives. You need to know what you did with each of them or what your people did with each of them so that when the time comes that you need to make changes or adjustments or solve problems, you've got the information you need to do it. The next step is policy development and governance. And I say that this is a foundational block of networking because I've watched what happens when companies don't do it, when they go organically into the... Now remember, I come from the time when all networks were installed organically. The original Apple networks, the original 3Com Ethernet networks, and Corvus OmniNet. You know, a lot of those grew up organically. People just kept on installing stuff. And when something went wrong, oh my God, we spent days crawling through it, trying to figure out where it went wrong. We want to do better. And today, those who document everything do better. Those who establish their policies up front do better. I mean, the whole purpose of having a firewall, what does a firewall do? A firewall enforces your security policy. Well, if you don't have a security policy, your firewall is useless. You have nothing to enforce. And that's true of your entire network. If you don't have policies for acceptable use, policies for who has access to what, role-based access controls, then you don't have a foundation for the political layer, the personal layer of your network. Start off with the policy that will undergird your ongoing governance of your entire network infrastructure. All these multiple clouds in your hybrid cloud infrastructure, That's your platform. That's your infrastructure. So be sure to govern it thoroughly. Now I'd like to share with you, going back to days of old, some hybrid homilies, things to remember when building your hybrid cloud environment. First and foremost, when you begin to plan and you've got your policy under development and so forth, know thy applications. Applications are everything. We build everything around applications. So start with the application. You begin with a complete inventory of every application running everywhere in your current network, however your network is currently constructed. You will encounter some legacy apps that were built in the days of monolithic coding, where everything was put into one huge monolithic block of code. And God forbid anything went wrong in that code, the entire thing could come crashing down. We've now moved off of that to what we refer to as cloud native. Cloud native because we're using microservices in containers, and those containers are highly portable. They can be moved around the network effortlessly, very fast. And the good news is if a container encounters a problem, it is discarded and reinstantiated instantly. It's replaced, and the program keeps on processing. So you have unbelievable resiliency in a cloud-native environment, taking full advantage of the rapid portability of cloud. You need to know the resources required for each of your applications. The good thing about containers, they each contain all the resources that that particular microservice needs. So it's pretty easy to maintain consistency of access to resources. But in general, you want to know each application, what resources does it require? You also want to know who's using it, in what department, on what server, how is it configured? Everything that you can know about each application needs to be in this comprehensive inventory. You need to know what capacities it requires. How much storage is it requiring today? How much has it grown in the last 6 months, the last year, so that you can project forward and forecast what your capacity requirements are going to last. Because ultimately, you're going to have to decide where in your hybrid network infrastructure each application is going to run best. Where will it reside? Will it be in a public cloud service? Will it be something we run in a private cloud service? Are we going to keep it at home? Where is it going to be? And in addition to running well, running cost effectively. You can get something running extremely well, but it could be extremely expensive. You need to balance between price and performance. So where will it run best? Where will it run most cost effectively? Those are the things you need to learn about each of your applications. Okay, next. Understand thy challenges. Okay, there are other minions charging the castle. The first of your challenges is over-provisioning. It's something that every network manager does because they have to guess. They don't know exactly what the capacities are going to be. They didn't get enough information from the line of business that's using the application, so they'd rather err on the side of over-provisioning than under-provisioning, because under-provisioning can be embarrassing. Over-provisioning can just be expensive. You choose which you prefer. Workload specification will constitute a challenge. What do you need to run a particular workload? How many processors? And you may have workloads that must run all in memory. That's a great trick, but it's doable. You may have to specify particular servers, particular server clusters to make that work. So you need to know that. You're going to need to be able to provide for performance analytics. Otherwise, you'll never know if what you're doing works or if it's working as well as it can work. Performance analytics will help you understand when you need to take certain actions. They'll also help you build your business case for the next improvement you want funded. So be sure you provide for that. And of course, performance analytics always include cost analytics, again, to help you build that business case and to help you know that you are running everything as cost effectively as you possibly can, because typically that's part of IT's charter. Deploy thy forces. Let's go charging down the hill and conduct a skills inventory. What skills do each of our knights possess and knightesses? What skills do they have? What skills does our new hybrid cloud environment require, or even a multi-cloud environment? What skills do they require? Do we have all those skills in-house, or are there new skills we're going to have to obtain? If there are skills we don't have, we're going to need to do some recruiting. So we need to plan out the recruiting that's going to take to find people with those skills. Or we need to build training plans to take our existing people and bring them up to speed on the skills we need that they can have to expand their capabilities, which is always a good thing, and be ready to have all the skills required to run our hybrid cloud environment. And of course, if anything should go wrong, we need to always have contingency plans. That means, are there partners out there that we can engage temporarily to pick up the slack if we lose some of our skill sets due to people departing, natural disasters, etc.? There have to be contingency plans in place to always be able to provide the services and the skills required at all times. Now, what do you think this guy's going to tell us? Choose wisely. I love that. He chose poorly. There are hundreds of services. Actually, there are probably thousands of services. There could be millions of services for all I know. But the point is there are tons of services. And each one has something to say for itself. Each one has various different capacities, features, things you want and need, idiosyncrasies. Some of them run across all platforms, and that's terrific. Some only run across one or two platforms, and you're very limited if you choose to use those services. But you may need them. They may be unique in the marketplace. Some are particularly designed for hybrid. Some are even designed for multi-cloud. Great. If indeed you've built that and you need that or you plan to build it, take a look at that and, keep in mind that you have that capability. They all have different specifications, so you're going to have to figure out how to marry them all together. Many of them have available APIs to make that easier. APIs also expand your opportunities. I mean, the reality is with a good API, you can connect things to things and create new automations that you never thought of before. You can create environments that are far less dependent upon users, which means far less exposed to potential user error. Not saying that people make mistakes, but they often do. They also all have different cost structures, and they vary broadly from one to one. You may be deciding between Amazon Web Services, Google Cloud, and Microsoft Azure. And you may find that they all have a particular service. And so that's making your decision harder. Well, before you walk away, go deeper, dig deeper, and find out what they mean by that service. The name that they give the service doesn't necessarily mean that it's the equivalent of the same name on another service. Different people interpret things differently. And you may find different services under the same name. You may find the same service under different names. So you have to dig deeper. You can't just look at the list of names and go from there. You've got to be much more circumspect than that. As we have more and more cloud services emerging, this gets more and more complex. I recently did a comparison between software licensing and cloud provisioning. And those people who thought that software licensing required rocket scientists, wait. We're getting way into the exosphere. The night also reminds us, don't do too new. All right, you don't want to be the test subject. Never install .o. We've been saying that for as long as I can remember. Never install the first version of something. Let somebody else test it and prove it before you do. New technologies are always emerging. And the fact is that a lot of them are open source. A lot of them all of them actually don't have a sufficient track record for you to be able to put your finger on it. And if you're betting your job on it, you want to know that it's going to perform. And a lot of them have been inadequately tested. They haven't been tested enough yet. Over time, the good ones will survive, the bad ones will go by the wayside, and you'll have a better choice of software that has proven itself. Much better choice to make. Don't do too new. Next, where should thy data go? Make no mistake, you have choices. No matter where you're running your applications, you have choices as to where the data goes. Okay, you may want to have all your data reside in private cloud storage. You may choose some public cloud storage services. You may even store some of your data on premise under the mistaken assumption that it has to stay inside your four walls. Well, if you put it inside your four walls and connect to the internet, you've just broken down one of your walls. So don't use that analogy. It doesn't hold. You need to decide where the greatest security is available. And it's often in the cloud. They can spend a lot more money on security than you can. It's important to level your storage. That is, things that are used every day should probably be in much more expensive, maybe solid state storage. Things that you barely ever touch should be in cold storage, very cheap, inexpensive storage that you'll only access very occasionally. You also want to put in place, and this is important, capacity monitoring for a good reason. You want to do basically capacity planning based on how much storage you're using now versus how much storage you were using 6, 12, 18 months ago to project forward how much storage are you going to need 6 months from now. Now, part of this is that you can provision more storage pretty quickly. If you over-provision storage, you're paying for it even though you're not using it. And so putting in place some capacity monitoring that supports good capacity planning, that allows you to save money by simply not spending on stuff you're not using, which is very logical. It's just a very common sense thing to do. I think capacity planning is developing into a fine art. And those that really put some concentration into it, when they do a study of how much they've saved, they themselves are shocked. So focus on capacity. Many people are putting their front end in public cloud. Basically, public cloud supports things like event handling. They have mobile interfaces available. All the tools you need to create a good UI are sitting there in many mobile cloud platforms. That doesn't mean that the data that you covet, that you protect, can't be somewhere else. Your back-end databases could be in a private cloud somewhere. You could even keep them on-prem if you still have that four-wall analogy cooking and you can't get rid of it. You can choose a much more secure place to put your back-end data and still take advantage of the front-end facilities available to you in creating your user interfaces. Now, you knew I would get to this, right? Shore up thy defenses. If you have hybrid clouds, you need hybrid security. Each cloud has its own vulnerabilities. Each cloud has its own specifications, its own requirements. You need to learn each one of them, and you need to learn how to manage them all together to make them play well in your sandbox. My recommendation is that, as with anywhere else, you pay special attention to endpoints. Why? Because endpoints are the doorways into your network, and into your resources. They are the likeliest place for anybody to enter, so that makes them the most vulnerable places. And while many people focus on the core, in hybrid cloud, there are multiple cores. You really need to also focus on endpoint. And honestly, none of your cloud providers are going to actually do that for you unless they are an endpoint security cloud provider themselves. So it's to you to provide endpoint security. Pay special attention in your network design to the places where data crosses from one cloud service to another. Those are opportunities for many cyber criminals to gain access. Sometimes they're very vulnerable because they're kind of like a DMZ. Nobody really owns that superstitious that overlap space. Wow. So be careful there. Pay a lot of attention there. And consider developing DevSecOps. Now, developing DevSecOps is not simply telling your development team, your security team, and your operational team, okay, guys, work together. I wish it were that simple. The reality is that, like DevOps, DevSecOps requires a cultural shift in your organization. Everybody has to be ready to participate. Everybody has to be willing to cooperate. And so it's a serious consideration. Worth study. Bring in a consultant who does DevSecOps conversions and talk to them about the challenges, talk about the expense, talk about the benefits that come out the other end. Definitely worth consideration. Yes. Which brings us to the ring. Now, what do you think I'm going to talk about here? Yes, we need one management platform to rule them all. We're going to go slay some dragons. Every cloud provides some level of APIs, and they're different from cloud to cloud to cloud to cloud. You need a management platform that can manage that variety of APIs, if at all possible. Every cloud provides different SLAs, and you, in turn, provide an SLA to your users. You have to be sure that their SLAs support your SLAs. Otherwise, you're leaving yourself exposed. So study those SLAs. Come to understand them before you start promising specific service levels to your user community. It goes without saying that each cloud has different features, different characteristics. And again, as we talked about before, they have different names for things. The way those things work varies from platform to platform. We've spoken many times today about, well, I've mentioned multi-cloud. Multi-cloud is not hybrid cloud. A hybrid cloud could be multi-cloud, but multi-cloud isn't necessarily hybrid. Multi-cloud means you're using numerous versions of the same kind of service, the same public cloud service, the same private cloud service. The best example, the one that everybody points to in multi-cloud management, is using Google Cloud and Microsoft Azure and Amazon Web Services all in the same environment. And it definitely adds layers of complexity, few of which we haven't spoken about in this session, which is good. But you need to be aware of them, and you need to pay special attention to them. And you need to be constantly monitoring those differences because they change. And when they change, you may want to change. And so somebody's got to stay on top of those changes at all times. Your goal in this management platform is to provide that elusive one single pane of glass, a singular interface, one place where your network managers go to control everything, to manage everything. When you have that singular platform, one big advantage is that there's less training required. You don't have to train people on multiple tools, multiple products, multiple platforms. And the other thing is, and this is important, it's easier to compare performance and cost between them. That is by far the most important thing of all. We just referred to it talking about multi-cloud, but it's true of hybrid cloud. Your job is not only to provide the most efficient network environment possible, the most efficient compute environment possible, it's to provide the most efficient platform possible at the lowest cost possible at all times. And therein lies the trick, is keeping it the best at all times. That requires constant monitoring, constant management, and the simpler you can make that management, the more you can bring it together, the more you can get closer to that single pane of glass, the better. With that, John, do we have any questions?
I think we've got a couple. Thanks very much, Howard. Let's see here. I want to remind the attendees that you can type your questions into the Q&A box at any time, and we'll definitely jump on them as soon as we see them. Let's see here. There's a question here about regulatory compliance. Can you say more about that? Does the cloud provider have to be certified?
Cloud providers need to be certified to specific standards. Here's the difference. In terms of regulatory compliance, you have to be certified. You have to achieve and maintain regulatory compliance with any acts that impact your business. That means that no product unto itself can be compliant. They can contribute to compliance, they can enable compliance, but just by putting them in, that doesn't really do a lot, because most services connect to people. And most regulations don't only specify what technology you're using, but they also specify what people have to be doing. And you have to be able to document that they're doing it effectively. And you have to be able to document that the services you're using are doing it correctly and effectively. In many regulatory environments, the providers have to be certified business associates, BAs, so that you can actually use them. You're best put to use those that have certified, because then they can contribute to your being certified. But it's important to remember that being compliant is something for you, not for your providers, not for your equipment. And also, compliance and security are two vastly separate things. A lot of people use them in the same breath, security and compliance. They're two completely separate things. You could be fully compliant and not be secure. And on the other hand, you could be incredibly secure and still not be compliant. So you need two different management teams one focusing on each, and working together to make sure that they each contribute to the other one's mission.
Fascinating. I think this question must have come in early, but it says, isn't security really the cloud provider's responsibility? I think you pretty much adequately answered that, but maybe say just a little more about who's responsible for security, just to drive the message home.
Sometimes, I hate to say it, but it boils down to who can you sue. And I changed that question to under what conditions can you sue? Realistically, as long as the cloud provider can prove that their systems were functioning properly, as promised, as contracted, they're fine. There are, if somebody, for example, were able to compromise one of your endpoints and get in, and even if the cloud provider couldn't prove it, you'd have to prove that it wasn't before you'd be able, they're innocent until proven guilty. It's very difficult, if at all possible. And realistically, as I said during the presentation, it could be a career-threatening event. So you really don't want to have that take place.
Mm-hmm. Yes. Here's one. You mentioned a few times how important APIs are. Maybe say again why they are so important.
Sure. Application programming interfaces. Try and picture, let's use one that you can all relate to. You're sitting at your remote monitoring and management console, and you're watching your customer's network. Okay, And all of a sudden, one of the little lights turns red. There's a router in trouble, and you see it, and you do a quick investigation to see what's going on. What do you do next? Well, you know that you need to action that alert. So you swivel in your chair, go over to your ticket console, and you enter a new ticket, copying in all the information. That's a lot of typing. It's really easy for you to make a mistake. It's also incredibly inefficient and time-consuming. Wouldn't it be great if your remote monitoring and management system could talk to your ticketing system? That's an API. An API connects those two together. And so it gets the data from the RMM, translates it into the way that the ticketing system needs to see it, and conveys it to the ticketing system. That's a small example, but you get the general concept. It enables different products, different software, different applications, different platforms to exchange data with each other and to continue processes between each other. And I think that's incredibly, it's so obvious how incredibly valuable that is when you think about how much human time you can save and how much human error you can eliminate.
Fascinating. I think that's all the questions we have for now. Remember, folks, you can put your questions into the Q&A box, and maybe Howard will have a chance to follow up later on. But that's all we have time for now. I guess I had one quick question. So if you don't think people know what a run book is, do you think they know what a homily is?
Yeah, because I think there are religious environments in which you encounter that word. Some people still live in Pennsylvania. They would know what a homily is. Yeah, good point. Well, good point, John.
Well, thanks, Howard. Let's see. We'll just wrap it up here. I want to thank our presenter, Howard M. Cohen, for a great session, and our sponsor, Nutanix, for making it possible. We're going to take a short break now, and we'll be back at the top of the hour for our second session, Top Hybrid Cloud Data Do's and Don'ts, presented by IT thought leader Joey D'Antoni, and moderated by my esteemed colleague, David Rammel, Editor-in-Chief of Virtualization and Cloud Review. I know this is going to be another great session. Now would be a good time to check out those resources on your console provided by our sponsor, Nutanix. And remember, during today's third session, we will be giving away a Surface Pro 7 tablet, so stay tuned. Thanks, Howard. Bye for now.
Welcome back, everyone. The event is now live. David Rammel, please take it away.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers, my fellow moderators, and of course our sponsor, Nutanix, for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, and I'm here to moderate the second session of our Hybrid Cloud Data Summit called Top Hybrid Cloud Data Do's and Don'ts. Our speaker for this session is Joey D'Antoni, Principal Consultant, Denny Cherry and Associates Consulting. Joey is recognized as a VMware vExpert and a Microsoft Data Platform MVP and has over 20 years of experience working in both Fortune 500 and smaller firms. He has worked extensively on database platforms and cloud technologies and has specific expertise in performance tuning, infrastructure, and disaster recovery. Joey, it's great to have you here. Please take it away.
Thanks, David. And hi, and welcome to Top Hybrid Cloud Data Do's and Don'ts. And this is something I've been working on for a long time. We're going to talk kind of generally about the cloud, but we're also going to talk a lot about data and how it flows in organizations. One of the most challenging IT projects I think I've ever done was I built a hybrid cloud in Microsoft Azure back when it was still called Windows Azure, maybe in like 2013. And it was really new to all of this. We built a VPN to the cloud. We built a database server in VM. And we fought with the product team a lot back and forth to make sure everything worked. And we've come a long way since then. It's a lot easier to migrate your VMs to the cloud. And we'll talk about just kind of all the different layers of this onion that you unpeel when you talk about hybrid cloud. And despite what any organization says about cloud migration, it's not an easy, simple solution. It's always complicated, and that's one of the reasons why we almost always end up in some sort of hybrid cloud model, just because there's not all systems are going to fit easily in the cloud. Maybe you have a mainframe, maybe you have other stuff. We'll talk through that in the session. We'll talk about monitoring. We'll talk about network. And I'll talk a little bit about data and databases. And I'll also talk about kind of different approaches that I've seen organizations take to move to the cloud. Like I mentioned, I'm Joey. That's my ugly mug. You can read my column at Redmond Mag as well. So some of the challenges of hybrid cloud, and first let me step back and what do we define as a hybrid cloud environment, right? This can be multi-cloud, especially something we see in larger and larger organizations. Some of those are multi-cloud by design. Some of those are hybrid/multi because some division wanted to do things in Google Cloud or maybe Amazon, and the IT organization wanted to move things to Azure. But the first crux of the problem that we have is that there are two different security models that we have to deal with, and this is kind of brought up in the last session about the differences in security in the cloud. And I think the first step you want to think about when you talk about cloud security, and we'll cover this in some more detail, but is that it's almost like if you're used to using VMware or Hyper-V, it's almost like putting your hypervisor or your vCenter right on the internet. Obviously, there's more security involved in that. We can protect things, but you're exposing your control plane and those APIs and those sorts of solutions as a default to the internet. So you need to think about how to protect against that. You need to think about just how to plan security and who needs to have access and what needs to have access. And we'll talk through that as well. You can have two or more potential different network models. One of the things that I ran into last week, we kind of had a new potential client, and they were just asking about, hey, can we migrate a few database servers? Like, how hard is this going to be? Is that, one of the things you have to do before you migrate a single server into a VM in the cloud is you really have to think about what your network architecture is going to look like. And that comes down to several things in terms of networking, security, just IP space to make sure you're not having overlapping IP space. And these things can dramatically affect the security stance of your cloud model, and they can also affect the cost if you don't do things well too. And we'll talk through that. Each cloud provider has different APIs and automation, and this is something that can be one of the benefits of, maybe picking a third-party solution to do some of your deployment models. I know a lot of customers really like to use Terraform because Terraform is kind of an open source infrastructure automation language, and that allows you to interact with a wide range of APIs, whether it be Azure, AWS, even VMware, or even some physical providers, so you can even deploy physical machines with some of the things Terraform does. Alternatively, like if you're using a hybrid solution like Azure Stack or Amazon Outpost, where you have a representation of a public cloud provider in your on-premises environment, you may want to stick to that cloud solutions because you can just have one different approach. And then finally, I think the other challenge, the two big infrastructure challenges I always tell people are networking and storage, because they're pretty different in the cloud. I find networking is a little bit easier mainly because you have the ability to kind of easily tear it down. Storage, once you get a lot of data stored, it becomes a lot harder to move. Even though the networking in the cloud is great, if you have to move 20 terabytes of data, you still have to move 20 terabytes of data. So I think having a good understanding of the different types of storage that are available in your cloud and are going to be key in understanding how you use those different storage types and where you use those different storage types. And I think one of the other things, and it's not addressed on the slide, but is understanding your organization. For any of those of you who are in IT management or have a management focus, like you're an architect, you really need to think about the skill sets that you have and in your organization and how you can deploy those and where they're going to get the most benefit. Because having the skill across multiple environments is always going to be a big challenge. And skills are probably your biggest challenge in all of this. So some other hybrid cloud challenges. I've been a consultant now for about 8 years, I think. My last real non-consulting job I was an architect at Comcast Cable, and one of the things I did that was my job before we built our own cloud there, which was kind of a fun project, but one of my jobs was to make sure we could understand what everything in our environment cost. And this is a really cool exercise. It took a lot of time, and I had a lot of conflicting numbers because when you have, for example, a building with a data center in it, but it also has employees, how do you balance out the power and cooling costs for the employees versus the servers and who needs what? So you're going to have two different cost models. You're on-prem. If you're a really mature organization like that, you may have a pretty spelled out costing model. In my experience as a consultant with other organizations, it's pretty rare that an organization can tell you exactly how much they can charge. So that's one challenge you're going to have is just understanding the costing model. The other side of that costing model is cloud challenges, right? So I like to call this the single bill problem, and it's a management problem more than anything else. But your management now gets a single bill for the cloud, and it looks really expensive. It's got all of your charges on it: your network egress, your VM storage, your VM compute utilization, your VM storage cost, other storage costs, storage utilization, all the little things you didn't know that were billed as line items. They get billed as a single bill, and I don't think the cloud's particularly more expensive than an on-premise environment, and I think in a lot of cases it's cheaper. But at the same time, your management gets that single bill. So one of the strategies you want to have before you go into this hybrid cloud implementation is understanding how those costs are going to be presented and taking advantage of governance options like resource tagging that allows you to identify what departments or what applications or which developers are responsible for the cost of which cloud resources. That can bring some clarity to your bill and help you better explain the high cost. The other challenge, I think, is dealing with legacy systems on premises. There's been some efforts to be able to migrate mainframes It's not something that is broadly used that I've seen. Most customers that have mainframe systems still run them in on-premises data centers. And usually when you have a mainframe, there's also a bunch of other systems that hang off of that. And how you manage that in terms of a cloud deployment, like are you going to move those systems into the cloud? Are you going to report from the cloud against that mainframe? You could have high network egress charges around that, which we'll talk a little bit more about how that works later. But just dealing with those legacy systems and how you manage them can be problematic. The other scenario here is when managing two different monitoring systems. You may have your own monitoring system on-prem from a third-party vendor. It may work in your cloud, and we'll talk a little bit more about this later too, because I think it's a really important thing. Or the other thing you can do is take advantage of the cloud monitoring solution, even in your on-prem environment. So one of the solutions I've used is Microsoft has a solution called Arc for VMs, and Arc for VMs allows you to effectively do the same monitoring you would do in Azure of VMs that are not in Azure. So they can be in your on-premises environment, or they can be in AWS or GCP. And that's a solution that gives you kind of a common experience with monitoring. So let's dive into monitoring a little more. So monitoring across cloud and on-premises can be a challenge. And one of the things I'm going to say here is you need to think about how you, what you think about in terms of the types of things you're migrating to the cloud. VMs or virtual machines are very much like one-to-one cloud migration solutions. If you have a VM on-prem that uses a monitoring tool, let's say agent-based, it's going to work exactly like it does on-prem in the cloud. It'll go to a server, probably a centralized server. You'll have the same reporting tools you have, all that. So as long as you're in VMs, that's fine. Where this gets tricky is when you want some cloud-specific monitoring. So some of the things the cloud can do for you is give you some advanced analytics, like can feed into log management solutions. Both Microsoft and Amazon kind of both have their own version of Splunk. It's log analytics on Microsoft. I forget what it's called. But that takes advantage of cloud features and streams into them. The other scenario is that you may, as you move into the cloud, and this is something I've seen with almost all of my customers, as you move into the cloud, you start using more advanced features. So you're using some features that you might not otherwise have used until you got there. So effectively platform as a service solutions, and they're important to you and you want to monitor them. Some of your on-premises monitoring tools may not work for that. Don't worry, your cloud provider has a solution for all of these things. They have built-in monitoring tools. However, they may have additional costs associated with them. And it's important to understand the costing model of those things. This is a general thing. It's always important to understand what anything costs in the cloud and what the model is. So is it, oh, hey, I'm monitoring a VM. It costs $5 a month to monitor that VM. Or if the VM gets really busy and starts emitting a lot of telemetry, is it going to cost me $500 a month to monitor that VM? Understand that, and that's really just a key general thing of cloud economics, right? You want to understand fixed cost versus variable cost and what those are. And then finally, don't forget to keep monitoring your on-premises systems. If you go all in on the cloud and look at a solution and understand that. So that's kind of the summary of monitoring. Cloud monitoring is not a big deal to me in terms of like a technical challenge. It's more an organizational challenge as to thinking about a solution and kind of blowing past the smoke of the vendors, because a lot of vendors will say they'll have a cloud solution and it really just monitors VMs. So if you're going to go beyond VMs, it's important to understand that. So why does the hybrid cloud even happen? And I have a couple of stories here. Not all systems are easily moved to the cloud. I mentioned the mainframe. I also had a really weird labeling system that required a hardware key. And this is a $4 billion medical device company, and we couldn't ship product without this labeling system that ran on SQL Server 2000 on Windows 2003. And this was in like 2011. We were still running the same system, and we couldn't even virtualize it because it had to have a hardware key. Those kinds of systems definitely exist in companies, right? Like when you're not an IT company, shipping product is your most important thing. And if you can't ship product because you have to run some system on Windows.old, you still have to run Windows.old and figure out a way to run it. Some applications you have may be business critical and or face political challenges in migration. I see this a lot too, where an organization will have something important, something like maybe a billing system or maybe any kind of a customer relationship management system that the application team is really hesitant to move to the cloud. So those systems tend to get left behind. And then finally, a lot of times cloud migrations will start at relatively small. So you might just have the idea where you want to migrate a subset of systems. You might be looking to do some monitoring systems in terms of IT solutions, whereas if you're not doing that, maybe an IT management system, any sorts of small systems, this is how migrations typically start. It's almost like a curve. Like there's a gradual build up and more stuff will get added. And then eventually, as your organization matures in the cloud, you'll grow there and you'll start kind of building all new systems there. But hybrid cloud happens almost everywhere, especially if you have a large data center footprint. It's just simply really challenging to migrate all of that to the cloud. I don't know how many of you have ever taken part of a large-scale data center migration project or data center consolidation project. But those things are really challenging. And even though the cloud gives us a bunch of cool automation and APIs and easy ways to deploy stuff, it's just never that trivial in terms of actually doing the migration. Even I've seen customers that were using VMware's cloud solution on both AWS and Azure, and even then they have stuff that falls behind. And honestly, that's about, to give some credit to VMware, their solution makes it about as easy as it possibly can to migrate. You really don't have to change anything, but still things will fall behind. So what is a hybrid cloud? The first thing you need in order to have a hybrid cloud is to understand some kind of network connection to the network provider. This could be as simple as connecting to your email provider like Office 365 over port 443. It can also be as complicated as having a simple hardware VPN, or you can have a dedicated connection to your cloud provider. So Microsoft and AWS both provide this, Microsoft in the form of ExpressRoute, and Amazon has a feature called Direct Connect. These solutions have a pretty high cost, but if you're needing to move a large amount of data across that pipe, it's going to be the biggest solution. In terms of the amount of downtime required for migration, the biggest limiter is how much network bandwidth, just simply how much network bandwidth you have to get data migrated into the cloud. It can be okay. Like I once migrated 40 terabytes of data in a really long weekend over a 1 gigabit connection. I still don't kind of know how I did that, but it was more than a single 1 gig connection, and it was really, really messy. So it was probably more like 2 gig, but it was just not a real fun experience to try to do that. So having the dedicated connection in place for a large scale migration can put you in a good spot. These things are pretty expensive. You have to pay both your cloud provider, your ISP, and if you're at a hosting provider like Rackspace or any of those other big colo providers, you might have to pay them as well. So understand what the costs are. This can also limit your downstream egress costs potentially, but having this solid network connection in place is really the first part of any kind of a cloud solution. I spend a lot of time talking about networking here and it's not by accident. I didn't, accidentally put in the networking slides heavy. It's really the first thing you need to do and plan before you really do anything else. Just like you wouldn't build a building that didn't have plumbing to it, you need to build a network setup before you have a big cloud. And you can start out, you can phase this approach too. You can start out by having a simple hardware VPN just to get a few things in place. For example, our company operates with a simple hardware VPN. A number of other small and medium customers of mine do that. But anybody who's really large will have that dedicated connection. And I've even worked with one company that lives in a data center that sits between an Amazon data center and an Azure data center in Virginia. And they have a cross connect between the two systems, and it's all fiber optic and very fast. That would be the other extreme in terms of cost from our setup. That's a few $100 VPN that we have. But getting that dedicated connection in place is probably the first thing you want to do. So you want to work with your network engineering team. You may face challenges doing this if you're working with a third-party provider because they don't really like you to move out of their solution and into the cloud. But just be aware that there can be some lead time on this. Technically, it's not that challenging. If you have full control, you can set up a VPN connection in a couple of hours. So the technical focus here of what I wanted to drill into and go a little deeper on is security, networking, and storage. And I know we're talking about data here and what to do with data. Databases are all fully dependent on these things. Network isolation, what kind of storage you use for those databases, that's all going to matter. Whether your databases are going to run on-prem or run in a platform as a service model in a cloud offering, or run in VMs. I'll call some attention to that, but the security, the networking, and the storage are really the things that matter to that. The databases just kind of fall in place and really are part of your infrastructure. So I feel like the hottest topic that I've been talking about the last couple of years is security. We can't go a week without some major company having a major ransomware attack and dealing with all the ramifications that fall from that, or having major supply chain attacks. I saw this morning that a major library in Python was hit with a supply chain attack where somebody dropped a credit card skimmer. A credit card skimmer and I think some other PII gather solution into a major Python library. So that basically puts anybody who uses Python in their application at risk. Cloud security is multifaceted and complex. I mentioned earlier about it's kind of like the equivalent of putting your VMware vCenter on the internet. It's not exactly that. We do have a lot more security options. So most of our customers that are working with Azure use the native security options, which is Azure Active Directory, which can integrate with your on-premises Active Directory. That's really popular with a lot of our enterprise customers. Our customers who are using AWS, for the most part, I find them to use third-party solutions like Okta and Duo in conjunction with the native AWS security to provide dedicated security there. One of the things you need to understand about the cloud model is that you're typically going to be using a kind of a more modern form of security than you might be using on-prem. So if you're using Active Directory with Kerberos in Azure, you're going to be using Azure Active Directory, which is SAML and OAuth, and those are newer, more modern solutions. The challenge you may have for application security, if you're using that, is you need to make your applications work with those security models. But just in terms of basic cloud security, you're not going to see that much of a difference. It's just going to be the protocols that are being used. So the first part of security is limiting who has control to the access plane. This is most commonly known as role-based access control, and we'll talk a little bit more about it on the next slide. We have lots of different roles, and this authorizes who in your organization can do what. These cloud permissions tend to be very IT focused because in general, when we're talking about control plane, you're not really necessarily needing to have business users go into the cloud and do something. They need to be able to authenticate into an application, but they don't need to be able to deploy a VM or make changes to a storage account. So it's important to understand those things. And control plane access is really the first point of security. The other thing you want to ensure is that anybody who's logging into your cloud management console has a multi-factor authentication. You don't want people to just be able to attack and use password spraying. The second part I think that's kind of important is understanding cloud identities and what applications can and need to do. I'm fresh off passing an Azure security exam last week, so a lot of this stuff is really front of mind for me. But so with application identities, if you've worked in a Windows world for a long time, you can almost think of this as the functional equivalent of a service account for a Windows application. So an application in your cloud platform is going to get assigned an identity, and if it needs to authenticate to any other cloud resources or get approved to access a resource, you're going to use that managed identity that you gave it. And one of the things that's important to frequently audit, because this happens a lot, is that you don't overgrant those permissions. You always want to follow a least privileges model, where you're providing only what those things need to have, and not so much anything over that. General best security practices, the same thing applies in the cloud. These application IDs sometimes, especially if you're deploying through normal means, they'll get over-granted a lot of permissions, and I think it's important to kind of monitor. And there are tools out there that'll do it. Part of Azure Active Directory solution is they provide access reviews. If you're on a premium tier, you can even use privileged identity management and limit when those things can go in. So you have all sorts of controls there. This also leads into network controls and firewalls. In our last session, we heard a lot about endpoint protection, and the clouds do a pretty good job of monitoring endpoints. They give you controls, they give you audit logs. I know both Amazon and Azure have endpoint management solutions that can collect and log data from all those endpoints, so you can see anything that's authenticating. There's some machine learning that's built into those that will allow you to do analysis of whether or not you're seeing evidence of bad behavior. And we say bad behavior, we mean trying to elevate permissions, trying to move laterally when you maybe don't have those permissions. Those are the kind of things you'll see, bad actor applications trying to do. Networking and firewalls kind of builds on that, though, because you have control and you can prevent the amount of lateral movement that any given application or solution does. So understanding that is really important. I think the other thing I want to mention here, since we're talking so much about hybrid, is that really the first thing I do in any kind of a hybrid deployment, especially for kind of a legacy hybrid deployment, is get a domain controller into the cloud. That should be an Active Directory site for you. So once that VPN is in place, I want to be able to authenticate users up there. I don't really want to have that traffic going back and forth. It's an encrypted connection. I don't have any concerns about that. It's just everything works better if you're in that one place, and there's not a whole lot of reason to not do that. And that's when I say that's my first move. If you have AD, I usually do that, and then get integrated with the cloud identity provider so that you have those identities synced, not just across domain controllers, but in the case of Azure Active Directory, in the case of Amazon IAM. And then finally, my last word on this slide about cloud security is if you're using Amazon S3 for storage, please don't just grant access to the public internet so that you can be breached like so many others have. We don't spend a lot of time on Amazon. It's probably 30% of my cloud work. But recently I had the chance to build something to match a customer environment. And it was really the first time I had to give S3 access to a specific application. And I didn't understand why it happened so much, because the user interface about how you grant access and how you give it an identity and then how you kick that back to your application is quite challenging. So I do feel sympathy for developers as to why there are so many open S3 buckets, but just don't do that. So it's the easiest way in the world to get breached right now. Or if you want to have an open S3 bucket, leave some phony data out there and let the hackers take that. Just to dive a little bit deeper on cloud security and talking about role-based access control, some of this is going to depend on your provider, but the general concepts are the same. And some of the same concepts, if you've worked with Kubernetes, some of these same concepts will apply. By default, there are kind of like three main roles. Reader, which can obviously read and see what any resources are and list resources. Contributor, so contributor can typically create resources but not assign permissions. And then finally, owner, who can also create resources, but also assign permissions. Depending on the type of cloud resources you're deploying, there are very likely to be specific roles that are associated with those types of resources, and those roles will carry with them specific RBAC permissions, and you want to understand what those roles are and what they've been assigned, which gets really difficult at scale. And this is where having audits and using some of the security tools that are built into the cloud providers can give you a good idea of when permissions have been over-granted. Understand your identity provider, and by all means have MFA. Multi-factor authentication is probably the single best thing you can do in terms of enhancing your security stance. We have it on all of our accounts at DCAC. It becomes a lot easier to set up in a cloud world because you don't have to stand up servers or anything. Potentially, you don't even have to buy another solution depending on what provider you're using. But it depends on that. Understand encryption and monitoring. So one of the things that I think is cool about the cloud, in the last session we talked some about meeting regulatory requirements. And one of the most common regulatory requirements across industries I see, and frankly a little bit useless, is encrypting files at rest. Encrypting files at rest is good. It means somebody can't run off with your files and without an encryption key open those files. The most common scenario we discuss when discussing this is if you had a database server, somebody stopped the services and copied the files to a thumb drive. They could not open those files on a different database server unless they had the keys. So these are important things to understand. But for the most part, all of your cloud storage is going to be encrypted by default. And then understand how you monitor that encryption so you can understand if those things are getting decrypted. The other thing to note is you want to understand if there's a key provider on your cloud. This is something that I frequently use in the form of Azure Key Vault. HashiCorp also has an open source tool called Vault. Those have separate security mechanisms from the rest of the cloud, which means you can hopefully you can store secrets there that only even admins can't necessarily directly access. So you can have additional layers of protection that will allow you to keep secrets out of your scripts and code. And this really matters a lot when you start to do automation. So networking, this is an image from a kind of common design pattern in Azure networking, but it's kind of a common general design pattern. I know I spent a decent amount of time talking about VPNs, but understanding how this cloud networking works can be a key part of security, functionality, and cost, especially in these hybrid environments. One of the things that's so important, and I run across it a lot more with my Amazon customers than I do my Microsoft customers, is that Amazon charges just about every place they can charge you for bandwidth, they charge you. So any downstream bandwidth for Amazon is extremely metered and billed. And I've never had an Azure customer complain about bandwidth charges. Almost all of my Amazon customers have, and their prices are kind of the same. But like in Amazon, any data that travels between availability zones, any data that travels between regions, more importantly, any data that travels back to on-premises is going to be billed. So you really want to think about your network architecture. Like, for example, you don't want to have, let's say, a database server that's in the cloud that's got maybe, big tables, and there's a big report that's pulling a whole lot of data back and running from a reporting server, or worse yet, somebody's desktop on-prem and pulling back 2 gigs of data or 20 gigs of data every day. That's just going to add up, and you're going to have a nasty surprise on your cloud bill. This architecture that I have on this slide here is what's known as a hub and spoke architecture in Azure. And what we have is the concept of a virtual network, which is where we have a couple of different subnets. We have a firewall for a firewall subnet, which will provide firewall services for our cloud networks. We also have a VPN gateway subnet, which is specifically known as a gateway subnet. That gateway is going to have a public IP address, which is going to be what we're going to point our on-premises network and in that VPN to. And then finally, the third subnet up at the top is a Azure Bastion, which is a remote desktop solution that allows us to securely remote desktop without necessarily having to come in over VPN. So also kind of a nifty solution. Then those networks are peered to other virtual networks where we have subnets within them. You want to segregate your traffic using subnets. There's different types of firewalls and different cloud providers, but where these are best applied is at the subnet level. So understanding those design patterns for how you want to lay things out is important. Really, one of the things that's most important is just understanding your IP space and understanding which cloud regions you're going to choose. Typically, you're going to want to choose the cloud region closest to your on-premises data center. You may want to choose an additional region for a disaster recovery region. You may end up in a scenario where you put some regions all over the world because you might put some data near where your customers are. And if you have a global application, this means you may need to spread that data across multiple regions to reduce latency to your customers. So thinking about that network design, thinking about your IP spaces up front, those are all really important things. And it is easy to undo some of this, but it's not easy to re-IP a whole set of resources, right? That can be really challenging. So plan for this. Even if you're doing a really small initial cloud deployment, plan like it's going to be big, just because that's something that is hard to work around later. So having that understanding, take care of that up front while you can. So data flows into the cloud are always free. This feels like some sort of drug dealer analogy, like get the first hit for free, but you can ingest all the data you want into the cloud, and the cloud vendor will happily take it and store it for you and charge you for it every month. Data flows, or what is more commonly known as egress, this is out of your cloud provider, is nearly always metered. Pick your currency there. I listed a few. Those are all the ones I remembered the keyboard shortcuts for. Out of cloud, so what that egress charge means can mean a lot of things. It can mean between cloud regions. It can mean out of the cloud, literally, where you're going back to your on-premises environment. But it can also mean things like availability zones, which are where you spread your cloud workloads across multiple data centers within a specific cloud region. Or even in some cases, just going between virtual networks in the same cloud, that data is metered and can cost you money. I say this is kind of a thing I see on Amazon more than Azure, but it's just something you need to be aware of, that you want to do proper design. And then I would always say try to avoid disparate patterns where your data and app layers are separate. You don't want to be hitting like a database server in the cloud and bringing that data back every day. One of the kind of interesting things about networking and databases is that all this stuff applies. We want to have our app servers close to our database servers. But now we're to the point where even with the platform as a service offerings that both Microsoft and Amazon have, we can fully isolate those solutions on private networks. SQL Azure was one of the first cloud services. Microsoft introduced it in, I think, 2009 or 2010. However, back then it was only available on a public network. Now you can isolate that privately. There are some scenarios where you may wish to have a publicly exposed databases, but for a lot of enterprise customers who are using those as internal applications, they don't want to do that, so they do want to put those on private networks. So make sure you have a pretty good understanding of the solutions you use. More and more platform as a service offerings in general are getting to where you can put them on a private network. So if you're choosing one of those solutions, have that discussion with your cloud provider and ask those questions. So cloud storage, this is going to typically break down into two basic conceptual types of storage. Object storage, which is files, backups, and blobs. If you're working with the cloud providers, this is S3 and Amazon, or Azure Blob Storage in Azure. This is where you'll store literally files. The key thing to understand about object storage is you're almost always accessing that object storage via an API. So you're not just hitting. It's not like you can just mount S3 in your VM and connect to it like it was the file server. So that's an extra hurdle you have to go through. A lot of applications support direct access to those things because they've interacted with those APIs, but it's kind of important to understand the concept. The other concept here is block storage, and this is storage for virtual machines. In Azure, these are called managed disk, Elastic Block Storage in Amazon. I would also kind of include file servers. Amazon has FSx, Azure has Azure File Storage. These are file server as a storage concepts. And these are two fairly disparate concepts, and these work, and more importantly, are priced very differently. Object storage is typically billed for what you use. There are some exceptions to this. It's not billed for what you allocate. And you don't really allocate storage anymore in blob storage for the most part. You just put files there. So you exceptionally have a consumption model. That block storage, which, by the way, is just object storage behind the scenes, just to let you know, but it's presented to you like it was a LUN on your on-premises SAN. That's going to be billed as an allocation model. So if you allocate 2 terabytes, you're paying for 2 terabytes, even if you're only storing, a couple of gig. And there are reasons why you may over or under allocate space. Typically, it's going to be in terms of performance, but it's important to understand those things. Block storage is fairly straightforward in terms of management. You really manage it just like you do on-premises storage. The one catch for that is for performance-intensive systems, like database servers that do a lot of IOPS. You may run into situations where you have to spread that I/O across multiple disks, and you need to kind of understand how you're going to do that. But in terms of your costing, it's very much X number of dollars per terabyte per month. Object storage is a different model for both pricing and storage. It's definitely an X dollars per terabyte, but there's also how frequently the data is accessed. So if you're in a situation where you have a file that's getting constantly hit by a busy website, the charges you may hit for the file can be very expensive. So it's important to understand that part of the pricing model and whether or not that's going to be impactful to your workloads. And just to wrap up, unless you're a startup, your cloud environment is likely hybrid. So if you're a startup, you're probably building everything brand new on the cloud. You don't have any legacy applications. You have whiz-bang developers. But in reality, most companies have stuff in the cloud and have stuff on-prem. I've worked at a cloud provider, and we had stuff on-prem. So it's definitely a case. So your hybrid is the new normal, in my opinion. Monitoring across these platforms can be a challenge, but there are plenty of tools both from the cloud providers and third-party vendors that will support your efforts. Cloud security is complex and really important because you have stuff that's kind of public-facing a little bit, or even really public-facing. but there are plenty of, but it's also very different from on-premises security. So take advantage of the tools your cloud provider gives you to assess your security footprint and stance. Networking and storage are also very different in the cloud, but this is a pretty well-defined space. There are a lot of well-known patterns for good designs at each vendor. So follow up on those resources, especially if you're an enterprise who's buying a large amount of stuff. Your cloud provider will probably give you some consulting money. Take advantage of that. It can help you get started and on the right track. All right, David, do we have any questions?
We certainly do, Joey. Great stuff as always. Thanks for that presentation. And I'd like to remind the audience that we can answer questions until about 5 minutes to the top of the hour in order to give you a short break before the next presentation, so send them on in. And let's get right to it. First question in the Q&A box is, what are my options for network connections into the public cloud, and what is the best approach for a medium-sized organization? What about an enterprise?
Good question. So, like I mentioned, you have the option of, just using a VPN appliance, and that's going to give you a pretty simple connection that's going to go over the public internet. It's secure, it's encrypted between you and the cloud provider. If you're a small and medium business and you really just want to start moving some stuff into the cloud, or not even moving, but building into the cloud, that's probably the way to go. If you're a larger organization and you need to move large amounts of data, and more importantly, you possibly have the need to move a lot of data back downstream from the cloud, so you have data flows that are going back and forth, by all means, you're going to want to get a dedicated connection, and you're going to have to work with your cloud provider to do that, as well as your ISP. And if you don't have your own data center, you may have to work with your data center provider for that. Some data center providers have those things in place, and you can just lease them for a number of months. Those are like the really big ones. Sadly, that's not that common, so you may have to buy a lease longer than you anticipate needing it.
Okay, great. Next question. How do you map your on-premises security into a cloud model? Is everything a one-to-one ratio?
Sadly, no. This gets kind of complicated. The first thing I almost like to say is, especially up front when you're starting to build stuff, who has access to your data center? Who has access to your vCenter? Who has access to your network control plane? Those are the first people who need to have access to your environment. And then as that grows, you can better deploy security and have a good understanding of what additional people, what applications need identities, what VMs might need identities to access other cloud resources. Those are all some things that you can think about. But initially, you want to get started with the folks that are building the stuff. It's not necessarily going to be a one-to-one thing, just because, your business users probably don't have a whole lot to do in your cloud control plane.
Okay, great. I'd like to remind the audience that we have plenty of time for your questions, so send them on in to take advantage of a one-on-one opportunity with a cloud data expert. The next question reads, what are the first steps an organization should take when planning for a hybrid deployment? Networking, security.
So you really want to think about the network space. That's kind of the first step, I think, and that's stuff you can do on a whiteboard. You want to get your network engineers in a room and have those folks map out, what your IP ranges are in all of your on-premises environments. The other thing those folks are going to help you do is map out if you're going to, when you're going to the cloud provider, which regions you're going to want to use, where you're going to have the closest connections, and they'll also potentially have the relationships you need with your ISP and such to help you get that direct connection if you need it. So networking is my first start, and then start to look at security and map that out. Who's going to be your security admins in the cloud? Who's going to manage that? what are you going to use for multi-factor? Those are the things I would look at.
Okay, great. Next question from the audience comes from Todd. He asks, any tools you can recommend to monitor traffic throughout the on-premises and throughout the cloud resources?
Yeah, I mean, I think any of the providers that provide, broad-based networking solutions. I've had customers using Quest. I've had customers using, I'll say their name, don't laugh, SolarWinds, that have been really happy. I've also had customers using the native solutions in terms of like Microsoft or Amazon, Microsoft Monitor or Amazon CloudWatch. I think both Microsoft and Amazon have those built in such a way that you can even run them back on-prem now. And if you're looking to just monitor network traffic, the built-in tools are really a great way to do that in terms of just overall throughput.
Okay. Joey, you mentioned that monitoring is an organizational rather than a technical challenge, and one of your 4 main challenges faced in hybrid cloud implementations. And I moderated a previous session in which the presenter emphasized that whatever you spend on monitoring is worth it. Do you agree with that?
Absolutely, I agree with that. Having observability and monitoring, and this kind of ties back into the security thing, but it also ties back into the uptime of your application. The more data and information you have, the more you can isolate problems. One of the challenges we had a customer where they had a pretty bad attack, and they're a small company, and they were on kind of the lowest level of a lot of things in their cloud platform, which didn't give us a lot of the monitoring we would have had if they were on a higher level. So what we're doing after the fact, we're kind of flying blind in terms of, what actually happened in this breach? How did they cover it? And just, I think one of the terms we didn't talk about enough in general is observability. And that's, what can we observe? How can we understand it? Those are all really important things, and they give us both a lot of insight into how things are being utilized. And in a cloud world, that utilization becomes really important, because if we're oversizing, we want to know it, and we want to be able to downsize and save money. That's one of the reasons why we're paying for the cloud. So I think, yeah, it's absolutely, and the reason why I say it's an organizational challenge is it's broad. And you typically have to get a lot of groups to agree with each other on a common tool. And there may not be one common tool for everyone, right? You may still end up with a couple of specialist tools. So bringing all of that stuff together can be an organizational challenge.
Okay. Kind of along the same lines, I've seen other presenters emphasize the importance of MFA, just like you did. Why is it so crucial and important?
There have been a lot of attacks. I know particularly on Microsoft because of Office 365 and some of the ways they have policies set up. And I'm presuming these happen on Amazon, where anybody can figure out what my login for Azure is. It's my email address. And then they can just start spraying passwords at it. Because I have MFA force enabled on Azure, if you try to log into my account, and good luck guessing my password, it's 64 characters. But if you do, and they're random, if I get in, if you get in, I'm going to get notified that you got my password right, and I'm okay. And I'm going to see that notification, and you're not going to be able to complete that authorization process because you don't have my phone or my face, which are the 2 things that are required for that.
Okay. Looks like we have time for 1 or maybe 2 more questions. John from the audience asks, do you have any suggestions for disaster recovery testing best practices using multiple cloud providers?
Don't do it. Yeah, use multiple regions in the same provider. That's my go-to. Unless you're really big and really good and you have a lot of people. So all these problems we've been talking about, security, monitoring, storage, networking, they all get like 4 times, not just 2 times more complex, they get like 4 times more complex when you go to another cloud provider. And that's kind of a serious statement. The one thing I'll say is if you want to have like a presence in another cloud provider to maybe give you like a static web page in the event of a disaster, that's fine. I strongly recommend against doing DR across cloud providers. I know there are a couple of industries that have regulatory requirements around it. I've heard of some banks in Switzerland. In that scenario, things are a little different. I would look at a third-party solution like Zerto, or maybe even using Azure Site Recovery. Amazon doesn't really have their own DR as a service. You can go from one to the other. Really, really hard to do multi-cloud well.
Okay, well, it looks like that's all the questions we have time for. Thanks again, Joey, for a great presentation and answering those questions.
Thanks, David.
Everyone else, stay tuned. We're going to take a short break and be back at the top of the hour for our third session, leveraging DBaaS to drive efficiency and performance in the hybrid cloud and beyond, and the giveaway of our Surface Pro 7. We'll be right back.
Welcome back, everyone. The event is now live. Scott Becker, please take it away.
Hi, everyone. Thanks. And welcome back to our third and final session of the day, leveraging DBaaS to drive efficiency and performance in the hybrid cloud and beyond. This is Scott Becker, Editorial Director of Converge 360 Media, which includes Virtualization and Review, Virtualization and Cloud Review, Redmond Magazine, and AWS Insider. I'll be your moderator for this session. Some quick notes before we start. We want to thank you for attending, so please be sure to stick around to the end. And not only because you'll be eligible to win that Surface Pro 7 in our random drawing, but also because as you leave, you'll be asked to take a short survey with your opinions of this event. So please share those honest opinions. I read those, and the rest of the editorial staff read those. We read every comment, and they shape our future events. And speaking of future events, we really want to thank our sponsor, Nutanix. Not only are we delighted to be associated with a company like Nutanix, but we know that they're sponsoring this event because they believe in this community. We want to support events like these, so please show your support and appreciation by downloading their resources and visiting their sites and contacting them for a demo. It's through their underwriting of events like this that we can bring you more summits like this one in the future. And so with that, I'm thrilled to announce our speaker for our third session, Chris Papp with Nutanix. And Chris has 19 years of experience in IT. Most of that time he spent leading and managing systems engineering and infrastructure teams. Chris is currently a solutions marketing manager for Nutanix, focused on the Era database platform. So Chris, welcome, and take it away.
Thank you. Thank you for the introduction. I'm happy to be presenting today, and I'm looking forward to it. As we said, what I'm going to be talking about is leveraging database as a service to drive efficiency and performance in the hybrid cloud and beyond. But before we start jumping into, how to use database as a service or why a company would be using database service, I think we've got to talk about the challenges that enterprises and IT run into and why they're even looking at moving to public cloud or a hybrid cloud setup. And, that runs into at the top level, whenever they're doing a database modernization scenario, the thing that we generally look at is the infrastructure being really complex. And in what I like to call a legacy environment, you talk traditional setups of storage and separate compute and separate networking and, lots of different silos in the environment. And that kind of bubbles up in a couple key areas of complexity and agility. And again, that complexity kind of pops up because you're looking at siloed environments that, different database engines, each and are set up on their own infrastructure, which means that you have areas in each silo that are, over-provisioned or under-provisioned. So you have a waste of resources, and you don't have them where they need to be. And that runs into the agility issue of getting what you need and when you need it. It's a common problem. It's what leads people to look at public cloud to begin with, right? That kind of ease of click and go, right? What you need today, you can expand out with that web, quote unquote, web scale scalability. And big customers today don't generally have that all the time. And you take that to the next level of just pure IT, but just for your database estate, which continues to grow, right? We continue to add more data to the environment, whether that's IoT data, or that's coming in that needs to be stored and processed, or that is true relational analytical data that is used to find competitive edge for a company or to find cost savings. We're getting more of it. It's getting put into databases. And so those environments are just growing at a good clip and a good scale. A good stat that I like to throw out there is that for every one production database that an enterprise customer has, there's 10 copies of that production database out there. And then in a survey done by IDC, they found that the average enterprise customer had 100 production databases. So doing the math, it's 1,000 databases that's the average. And now you have 1,000 different instances of where problems can pop up. There's not standardization. You've got to patch those. You've got to keep them up. You got to do upgrades. And it becomes very complex. You got to manage the applications that are attached to those databases. Not very agile. It's usually with a team that's very small or different teams that don't talk to each other. Trying to get stuff out the door. And those things in itself, that lack of agility and that increased complexity in the legacy environment, it comes at a cost, and that cost is high risk. Your database, your DBAs are on the firing line. There's a risk of not getting critical security vulnerabilities patched. When you're looking at the news, things that always pop up are customer data being breached, right, being exposed out to the world. And usually because I think there's been some high-profile events where a critical vulnerability update was not applied to those databases. So there's an impact to the brand, and if that happens, there's a cost associated with it. There's a cost to downtime. You take a database down inadvertently, or it goes down because of an issue, and you can't get it back up. The average for that is $35,000 an hour, right? So very expensive downtime that can occur. So, when we're looking at those things, risk, cost, complexity, agility are the challenges that are facing our customers when they're looking at moving to a public cloud or a hybrid cloud setup. So when they're moving into that kind of environment, it's important to see why they need those things, and it's not too hard. When we're thinking about public cloud, again, there's that elasticity, ease of use, and by elasticity, ability to scale up, that regional or that seasonal scale up for that retail customer, right? Or if your DevOps environment suddenly needs to double in size to accommodate a project, you can easily accommodate that. And you have the choice. You have many choices, and it's very simple. It's very intuitive. But on the other end of that, what you don't have if you're moving everything to public cloud is you have costs and you're losing control of your environment. And because of some of the things that we run into, specifically with databases, there's compliance concerns that can come up. That there's data gravity. Where does your applications live? They have your database and your applications need to live together. So a lot of that is requiring those databases to still live on premises. And there's benefits to that too. There's predictable costs. You can get high performance in the cloud, but it costs a lot of money. High performance equals high cost. Your compliance concerns, your data gravity concerns are addressed, but then you don't have that flexibility and that agility you have with the normal environment, right? So what we find are with a traditional legacy environment. So what we find though is customers need both. They need to kind of unify that, and they need that. That's where the hybrid cloud comes in. They're always going to be in some state of hybrid cloud, whether a majority of those databases are sitting in public cloud and minority are sitting in on-premises, or you flip that around. They're going to be in a state of hybrid cloud. That's just the way it's going to work. And so the complexity that comes up at that time is managing two different environments. If you have your databases living in AWS, now you need to manage that and manage those security policies, and the way you provision those databases are different than what you would do on premises. So there needs to be that ability to kind of unify both those environments. And given those factors, there needs to be a balance between them. Get the benefits of public cloud and the benefits of on-premises, and move the workloads where they need to be so it fits your company. So a couple things when we're looking at that, what capabilities should a customer expect in a hybrid cloud environment? And I think it's pretty straightforward. We talked a little bit about it. When we talk about value, it needs to be seamless, it needs to be powerful, it needs to be resilient. And what I mean by that is, if you could manage that hybrid cloud environment with single control and data plane and manage multiple database engines across the hybrid cloud environment, that's where simplicity comes in, right? And the powerful is provisioning and cloning and standardized database copies across multiple sites and regions. That needs to be there as well, right? That's the ability to on-demand elasticity and business continuity. It needs to that's where the resilience comes in. That lift to shift. You need to be able to mitigate risk and be highly available and be able to have your backup copies or your snapshots across multiple locations in case of a failure. And you need to support remote database operations. That's the new normal now, right? And enable remote workers to easily and rapidly migrate databases into public cloud and maintain business as usual operations, and then vice versa. We have to do the same. So, in a nutshell, if you can manage both your public cloud databases and your on-premises databases from a central control plane, that's gold, right? But that's not the norm. That's not what you normally see. It's still, you still have for each different database engine, it's a different management interface, and then where that is located, that's it. If it's in public cloud, that's a different management interface, and there's no standardization across those. And that's where like Nutanix comes in. When we talk about like the benefits of it and of that environment, we are able to kind of take a hybrid cloud database and simplify that. And that's where we talk about database as a service operations. What we do, in kind of a high level, is we provide the tooling and the capabilities to run database as a service on your terms on your data center or your private cloud, and in this case, a hybrid cloud. So when we're looking at the different database engines that you might be running in an environment like traditionally SQL Server, Oracle, Postgres, MySQL, SAP HANA, MariaDB, or as of the recent release for our database as a service product, Era, we're able to support MongoDB with that. From a central control point, we can manage those things. And the key thing about that when we talk about database operations is that, there's a lot of things that go on besides setting up a database that are kind of under the water. Hence the kind of the graphic that we have. It's an iceberg, right? Like once you get that database out there, what are those operations that need to occur? And there's a lot to think about, from provisioning to automation, patching, database protection, and cloning. There's a lot of work to do there. And so when you have it across multiple environments, multiple locations, availability zones, it makes it very hard. And our goal is to, just like everything we do at Nutanix, is make it simple, make it intuitive, make it easy for the DBA or the systems administrator to manage those and be able to get that stuff out the door so they're able to focus on projects and what's important to the company, so they can, line of business operations, so they can address the bottom line versus, that firefighting mode of, coming in and trying to fix a database that's been down overnight, or all the applications that were associated with being down, and get them up. And then that time to get those up is very hard and very long, because, at that point in time, every database that you have in your environment is a snowflake because there's been no standardization. So with, Nutanix, what we're able to do, and with Era, we're able to kind of address those kind of four key pillars in an environment. We're able to address provisioning, cloning, backups and restores, in-place restores, and then patching, so for database lifecycle management in those four areas. And we're able to do that as of today on premises and then in the public cloud, AWS. So with Nutanix clusters, we're able to manage a database sitting on AWS bare metal, that's sitting out in AWS public cloud, and manage that database from a central control plane. We also have Azure coming up. We announced that, so that'll be coming up as well. So we have the multi-cloud kind of capabilities in the very near future, and that just gives you the capability of wherever your database resides, you can manage it and have standardization as part of that. So what I'd like to do next is kind of jump into the demo. We can talk about it, but I'd like to show you kind of the value of what kind of having a central place to do all your database management, and be able to kind of demo that fairly quickly and very easily. So what we have here is the Nutanix Era login page. So when we come in, what we're seeing right here is the dashboard. And so like most of that dashboard, it's kind of a one-stop, kind of get an assessment of your entire environment and infrastructure. And kind of some key things to kind of point out here is like the data usage. One of the benefits of running database on a service with Nutanix is that we're able to save, because we plug right into the backend architecture and the distributed platform of our Nutanix cloud. We're able to save a lot of expensive storage that databases sit on. So in this case, in this environment, we have an average of 7.3 x space savings. So you can see what's used and savings over a traditional cloning environment. And then you can kind of see all the different sources and clones out there, the cluster versions. And then kind of right here, what we're looking at, we like to use the term time machine because we use a lot of the point-in-time snapshots in clones that you can roll back to. And so you can see for that particular database, the version, the size, and the different backups or snapshots or clones that you have out there, and the savings that are associated with it. When we look at like the databases, again, that kind of central kind of spot to see everything you're supporting in your environment. Like most environments, it's not a one database fits all. You're usually generally running multiple databases in their environment. You can see that kind of jump into each one if you want to, and kind of be able to see what how many you have, what's the clone versions, and again, space savings, because that's huge for us. We talked about provisioning. And so what I wanted to point out, when we provision a database, the key thing to think about is it's not always provisioning a single database instance in an environment. Like, that's simple. But when you're rolling out, like for instance, a SQL availability group, that can take, in a traditional environment, days, sometimes weeks, depending on the standards, procedures, and there's no standardization in that. What we do is we take like a kind of a gold image and roll that out with all the compliance and security built in. And in this case, if you wanted to roll it out in a hybrid cloud architecture, you could create a new cluster. And in this case, what we're looking at here, the different clusters we have sitting out there, we could roll it out to AWS and an availability group, and then our on-premise production data center, and actually deploy that out. You can use that with Nutanix. Or if we were looking at, for instance, if we were looking at deploying an Oracle cluster, Oracle RAC cluster, very complex, tedious, lots of steps involved. We're able to reduce that down to minutes and hours, depending on how many instances are in there, how many servers. And we're able to deploy that fairly quickly with the best practices for both the database engine as well as best practices for Nutanix to get the best performance out of it every time. So you're getting it out faster and getting the best performing database each and every time. Do you want to jump into some clones here? Let's look at actually Time Machine. Look at the different profiles that we have out here. Just want to quickly kind of walk through how easy it is. So we're looking at a finance database, finance DBTM. Kind of what we're looking at is the traditional calendar format. It's taking, I believe, every 15 minutes or every 40 next log catch up. So every 15 minutes, right? It's taking a full snapshot of the database. So if we wanted to roll back to Wednesday, July 21st, we could do that. And then once we click on it, we could do actions, and we could actually create a database clone from that. We could restore it to that time, or we do log catch-ups. One of the new features that we have rolling out is specifically with SQL is we can take a snapshot backup and deploy a new database from that, and then roll out a new database server with that. So it's a great opportunity if you're doing an upgrade. So moving from, SQL Server 2012 to SQL 2019, you take a snapshot of it and then roll that out to the new database instance that you built.
All right, super. Thanks, Chris. That demo was pretty cool. I like the that calendar view was so simple. It's really nice.
Yeah, I mean that's kind of what anything that we do. It's meant to be intuitive and easy. You think of like how you use your iPhone. You're not usually busting out a manual, right, to learn how to do it. It's meant to be very. It's with that kind of ethos and everything that we do. It applies to even database operations for day one and day two operations.
Yeah, great. Yep. So if you have any questions, go ahead and type them into the console, and we will we'll get them answered here. And Chris, maybe I'll just start off. So, what's your perspective on why customers are looking to the cloud to solve some of their database issues?
Yeah, that goes back to like at the beginning. They're looking to address the complexity an agility issue, first of all. They want that fractional consumption, that web scalability, that, the one-click actions to deploy a database, and then not having to hit like those limits that you do, like in terms of performance or capacity, that where now you got to go and procure and do a forklift upgrade to get past them. You don't have those limits in a public cloud database. So, with that, they're also trying to roll out, like, how can they get the best of both worlds when they're moving into the hybrid cloud. They want their data to be secure, and they want their databases to sit next to applications, but they still want that simplicity, that fractional consumption. And so I think that's why customers are looking to the cloud to solve those database issues, and then they're trying to address that with like a hybrid cloud architecture.
Right. Yeah, and I wonder if you could go through again. You had mentioned about four pillars of what you guys are doing with DBaaS, and it looked like maybe there was a slide missing or something. So I was just wondering if you could kind of go through what those four pillars were again, because I sort of missed it there, and maybe some people in the audience did too.
Yeah. So when we're looking at like the database as a service, how we do it in Nutanix, it's specifically database as a service, custom built for like the on-premise data center, right? Custom built for Nutanix specifically. And so with that, the four things that we address in the service pillars are provisioning, copy data management, so that's cloning and snapshotting, and specifically cloning and snapshotting that plugs right into a distributed storage backplane that is it's both faster than a traditional clone, and uses up about, on average, 6x less space. So huge cost savings and huge storage savings. And then there's lifecycle management. And what we term as lifecycle management is the patching and the upgrades of a database, right? So not just the critical vulnerabilities, but also the capability to move from Oracle 11c to to 19, right? To be able to make that jump, we're able to kind of make that easier and simpler to do, taking a lot of those kind of the minutiae steps that are involved to do that, kind of whittling that down, and then build some standardization in that. And then last but not least, there's the basis of any kind of backup plan is making sure you have sound backups and they're easily to be restored. So with our snapshot technology, we're able to take, because it's non-interrupted and because it's very fast, a lot of companies where they used to take a daily clone or snapshot, right, to offload that for a reporting server or just for restore capabilities, they're able to do it like every 15 minutes now. So they're getting, better restore capabilities. If somebody blows away a table, they're now able to kind of restore that back to within that 15-minute window where before they had to do it, do that from like the last full backup. So we're able to do that, and there's not a performance penalty and there's not a storage penalty that goes with that. So it's a win-win situation for them to take those snapshots more often. So backup and in-place restore. So those are the four main areas.
Super. Yeah, thanks for going back through those. And when it comes to, keeping all those snapshots, what do you recommend on the back end? Do you guys provide something, or are people storing those on premise, or are they putting them in the cloud? What are they doing with that?
Excellent question. So as of Era 2.0, which was released almost a year ago, they can actually, what we would recommend in terms of any just general outside Nutanix is, follow the golden rule of don't keep your backups or your production data as that. So starting with Era 2.0, and we're on 2.2 now, if you're in a hybrid cloud format and you're taking a snapshot of your on-premises data center, you can keep those snapshots now in the public cloud, or vice versa. You can have stuff sitting in the AWS availability zone and then keep that on-premise. That does two things. One, if you lose that site, you still have access to those clones and snapshots. But two, if you're trying to do things like offload that data for like a reporting server, or you need it for like dev ops purposes, now you have copies of that data where it needs to be, right? And it's much easier to do versus having to now copy it across the wire. So, for availability and disaster recovery purposes, definitely you can keep those in different locations.
Okay, cool. Hey, we have a couple of questions coming in from the audience, so let's get to some of those. The first one is from Michael. And you might want to read along because it's a little bit long, but it's a good story that you might be able to address. So he had an experience last year where his team was using AWS DynamoDB in the cloud. It was small, 3 or 4 tables, less than 10 gigs. It took several hours to perform a restore with no users online. So he's new to Cloud DBs, and it seems as if something is not. I guess the question is, what's your experience when dealing with NoSQL DBs such as DynamoDB, as far as recovery?
So I can tell it from the perspective of when we do it, and it's kind of cheating on what he's looking for in terms of like native cloud databases. Like in terms of NoSQL, we support MongoDB, and we don't see that. But it's also like where I've seen those run and tested have been on premises. We're using Era to do those snapshots and clones, and because you get the efficiencies of taking snapshots and clones using Era, and because it's plugged in using APIs plugged in right into that distributed storage, you're able to do those restores are very fast, right? Like faster than the average, I would say so, and the norm. I would say in terms of like what he experienced and having that in the public cloud, I have not seen that as a problem across the board where people are having long restore issues or long recovery times. I think it just depends on how big the database is, and we'd have to dive into that more. We could talk about it offline and get with some of our team members that on the technical side and have a bit larger discussion offline about it.
Okay, super. And we can get Michael's info to you so you guys can connect. Todd has a question. He says the one-click technology that Nutanix provides for Azure and SQL. He's wondering how involved it is to move SQL from on-premises to Azure, and is it driven from the Nutanix console or from within Azure?
Yeah, so what we do, so one thing to note, we have some early adopters on Azure. So Azure was announced, and I just want to make this quick caveat. So it was announced that it's coming. We have early adopters that are kind of going through it. I wouldn't see it coming out in full GA mode for maybe later on this year, without putting any timelines and dates. With that said, what we normally do, we don't get in the data pathway. Like what I mean by that is we're not replacing the database engine commands. What we do is like we're plugging into the APIs, and so we're using them on the back end. So the easy answer is like we're still using Era is passing on those commands to use via API to Azure or to AWS to do those things. Right? So in the case of in the only difference being is in the case of like Nutanix on AWS, what that is we're actually running Nutanix on bare metal servers on bare metal AWS, and I think it's going to be the same with Azure. So when we're doing that, we're still using the AOS platform, which is that's what we use for our cloud and managing hybrid converged infrastructure. So when we do that, we're still kind of using that same backplane, but we're still kind of sending those commands out to say if it's SQL or Oracle, right? That's doing that. When we're doing and to make it clear, and the same will be true with Azure, these aren't going to be like native Azure databases. There'll be databases like SQL sitting on Nutanix AOS, but in Azure, if that makes sense. It won't be like native Azure databases. Not in this version. Possibly in a future version.
Okay. All right. Another question from Paul, and maybe this is related. I forget what you were saying about SQL Server support, but he's asking how compatible is Era to SQL 2016 or SQL 2019?
Fully supported. Yeah, it's fully supported through and through. What we do is on both sides. Like we have a ton of customers. In fact, most of the customers that we have running database workloads on Nutanix in general is SQL. And so we do a lot of customers, because a lot of customers running on Era are running SQL Server as well. And so it's completely compatible with those versions.
Okay, great. Another question from Jim, and this question came in at 2:19. You might have been in the demo at that point. I forget the context of what he's asking here, but he's saying, can I present those database clones to other VMs? So I'm not sure what that means, but maybe.
So I'll take a shot at that. So if you're taking a clone of a database, like say DB Instance 1, trying to send that to another database, yes, you can definitely do that. In fact, one of the ways and use cases that we have is if you're trying to do an upgrade, or are you moving a database to a different location, or you're going from 2012 to 2019, you can take that clone or snapshot and then present it to a different database server and have a whole new database built off that database clone.
Okay. And this is more of a sort of an all-up Nutanix question probably, but Paul's asking, what kind of incremental cost is there if I already have an Azure private cloud but want to have better management of all resources?
We'd have to probably take that offline for sure, because I think there's nuances and there's specifics to what you're running, and then how we'd have to run it. That's definitely a case where we'd have to get with the account team and kind of walk through those all the way through.
Gotcha. The other question from Todd, do you have white papers and knowledge base articles that highlight the process of migrating from on-premise to, well, and this one is about the Azure cloud, so that's going to be, I'm sure that those kind of resources are in development. They can be reviewed prior to the process.
Yes, that's correct.
But any guidance for people as far as, maybe not Azure, maybe AWS, but just like where they can find?
Correct. Yeah, so Nutanix.com. So yeah, well, we have best practice. So first of all, we have best practice guides for each of the database engines. But if they were looking at moving something on how it works, we definitely have technical resources, technical guides on Nutanix.com. And moving those are, working with, AWS clusters and managing Era with that. So we do have papers written by our technical teams that can assist them with that. And you need to go to Nutanix.com/Era, ERA, and then kind of follow, to our best way to kind of get to that. We also have on that landing page, we have a YouTube playlist that has their how-tos on that playlist. So, how to deploy a database to Nutanix clusters on AWS, or how to provision SQL Server availability group in a hybrid cloud format, kind of what I was talking about earlier, where like the primary is on-premises, but the secondary, the high availability failover in that AG is sitting in an AWS availability zone. So it's a nice walkthrough by our technical marketing engineering team where they walk through. There's a lot of those videos out there on how-tos that can be found on the Era website.
Okay, the Era website, cool. A question from Andrew, and this is a pretty broad one. So he's asking, what's the best practice for app server, network, et cetera, monitoring across on-premise and cloud systems? Do I need multiple consoles and tools? I guess, if you want to tackle that one, great. But it might also be a good opportunity to talk about sort of like, I don't know if you remember the old breakfast cereal commercials, or, like Captain Crunch is part of this complete breakfast. Like what do people typically use alongside Era to sort of manage their hybrid cloud scenarios?
Yeah, so when we're talking about that, so one thing that we do, specifically in like if you're talking about monitoring, right, in just general basic monitoring, what we do and what we provide is there's some basics of how the environment's doing inside Era, but things that work with it, we team up with a lot of different companies, but whatever they're using today is like, and we also have, and I should kind of step back, because we are API driven, a lot of the major monitoring or application platforms out there, or even like, we can plug into those, even though, we can have something come up where an alert comes up from that monitoring platform, and then alerts it and then sends it to like ServiceNow, right, to create a ticket to go check something out, because we are API driven. So there is that capability. But when we look at that, the key thing there, and I think this is just general guidelines of practice, probably a little bit more high level and not the granular details, whatever you're using, find out what your baseline is across the environment. Right, that's true to form any environment. What is good to you, and then go from there. And that could be, latency. It could be end user efficiency. It'd be like how that application is running. But you generalize that in that case, you are gonna have multiple consoles. You're gonna have one for monitoring your tool set, and the whole idea of Era is to provide the tooling, everything you need for database as a service. So the idea is to simplify that and consolidate. So you don't need something separate for your infrastructure and for your database management. It's all there. And then using Nutanix Prism to kind of help with that. And then if you're doing any of the application automation, we have a suite of products that tie into that. So it's within that Nutanix suite. Like we have Calm, for instance, is our kind of lamp stack kind of automation. But we do work well with, Ansible or any of the other ones out there, where, they can turn you, if you're going to deploy an application stack, for DevOps purposes, for example, you can throw that out there, and then they can send an API trigger to Era to then deploy the database that supports it, right, with the standards and compliance and best practices.
Right. Gotcha. Well, Chris, it was a great presentation, great demo, and we had a great series of questions there from everybody in the audience. So thanks for that. Before we get on to the prize drawing, Chris, any sort of closing thoughts that you want to have people take away?
Yeah, in terms of a closing thought, whenever you're looking at a hybrid cloud environment, the key there is to find out what's best fit for your workload. And then, when you do that, it's not a one-size-fits-all. It's, putting your databases wherever you need to, and it's about choice and availability and performance. And so, making it on your terms. And then when you do that, like Era kind of simplifies that and makes it available to you, so you're not getting locked into one way of doing things.
Got it. Super. Okay, and now it's time to announce the winner of our random drawing. So congratulations to Jeffrey Wiggins from DSR Global. You've won the Surface Pro 7, so our team will be in touch with you on how to claim your prize. And that's it for the summit today. So thanks to Chris Papp. Thanks to Nutanix for sponsoring it. And thanks to our other moderators and presenters. It's been a great summit, and appreciate the audience participation and your attending today. So you'll get a replay email in the next few days. We hope you enjoyed the event, and please do take the survey that pops up when you exit. Thanks again. Have a great day.